And here we come to calculus, okay? And in calculus, you need to be able to find, they included limit of a function, but it's rare for you to see questions on limits. But generally, you need to know how to differentiate explicit algebraic and simple functions, okay? And then some simple trigonometric function has been shown here. You need to know how to evaluate them. And the same thing with integration. You need to know simple explicit algebraic expressions, how to find their integration, then simple trigonometric functions, how to also find their integration. But then for integration, you also need to know the area under a graph, okay? That graph will be bounded, like here it is bounded at point A and point B. So the area under the curve will be the integral value of that function, taking the boundary A and B as consideration. That means that after you integrate, you need to put in the value of A and subtract it from what you get from the value of B interpolated in it, and you get the area under the graph. Now, these are actually the basis for the differentiation and integration, but the application of differentiation is one area I know students normally do find challenging, and we are going to look at that right now. The areas that they generally test students on applications of differentiations include the maximum and the minimum value, okay? And for your maximum value, the second derivative should always be less than 0, whereas for the minimum value, the second derivative should be greater than 0. So those are means of testing. What you need to do is to find the derivative and equate it to 0. Normally, it always appears as a quadratic function. So if you differentiate that quadratic function, you get a linear function. That linear function will be of the order y is equal to mx plus c on co. And then you can equate that to 0, solve for x, and then to find the maximum or minimum value, which is y, you put that value of x back into the original equation to get the value of y, okay? So that's one application of differentiation that they feature it quite often. They feature it a lot. Another one is the rate of change of volume with respect to radius, just rate of change generally, okay? In which once you know the particular equation that you are looking for, you only need to know what they are finding the differential value with respect to. Like here in this case, the rate of change of volume with respect to radius will mean that you differentiate with respect to r, and then you can input the value of r. Maybe they ask at a particular point, you can input the value of r, and you will get your solution out and fine. Now, this other case is a case in which you are given a particular function and a polynomial function, and you will be asked to find the normal at a particular point. So you don't need to be scared. All you need to take is that particular polynomial function, like here, the function y, then solve for dy dx is equal to 0. That will give you a value of x, okay? And then in that value of x, you can help you to get the tangent, because normally if you solve, you are going to find y is equal to mx plus c, something in that order. That m, the coefficient of that x, is going to be the slope of the tangent. And then from our understanding of coordinate geometry, we know that the normal to that tangent will carry the negative of the inverse of that slope. So you just need to use that, and you can get out the equation of the normal as appropriate, okay?